Yeah, this is just going to be very quick today. I just want to test out my new equipment. I got a new monitor because my old one of my old monitors burned out, and I got a new headset, stereophonic headphones, and microphone set. And I haven't streamed for a while, so I'm just testing out this new setup. I have a new installation. I fixed some software problems. So very quickly, I'll look at that. I will go here. Go to live streaming, and we'll see that in fact yeah, I don't know what the delay is here, but I'm not concentrating on having the least delay possible. It is in fact working. So let me just, so I set up a new repository. So I could play with this. That's running on just one core of my Haswell 8-core i7-5960X HT, let's see, 3.8 gigahertz. It's running on just one core, so this is not a multi-core app. So it's a Turing simulator, and it's basically like the game of life, Conway's Life, except that I'm not looking at a neighborhood of 8. I'm looking at only the neighborhood of 4, the orthogonal neighborhood. I think. Of this one, no, I'm looking at the neighborhood of 8. Let's see. This one and minus 2. I'm looking at the neighborhood of 8. And the rules are here. They're real valued rules, however. So the meshes are integer, and they have real values in the rules. But other than that, it's a cellular automaton, basically. An integer value cellular automaton where let's say a real value cellular automaton. And the rules are, you have basically one rule which increases and one rule which poisons. And the rule varies, as you can see, across the mesh. And pretty obvious how that works here. So these are the constants which are used in the rules. A is used right there. B is used here. C is used here. This is the poisoning step. This is the poisoning rule. This is the burgeoning rule. And you see that we have an organized pattern of spirals, which is stable, and a pattern of stripes growing and escaping off to the left. And then we have a chaotic region at the right border. And that variation is generated by the fact that I start out the constants. I start out these constants, semi-constants in one case, that apply in the rules, are used in the rules A10, B20, C 0.3, and then I increased A by 0.3 every time I step I, and I steps from 0 to 2, from 1, say 1 to 248. So that variation of A, which is the only parameter that changes in the rules, the two rules that apply every step, along the I-axis or the x-axis, so that A is, I'm not quite sure if A is increasing or decreasing as you read X as increasing or decreasing. So I'm not quite sure the stripes escaping off to the left, if that represents A as 10 or A as like something like 80. No, I am pretty sure. So off to the right, that's the highest value of A after they all get added. And to the left is the low value of A. And so that's adapted from this demo that comes with the operating system and has been there for the past decade with the distribution of this operating system. The Turing demo. It's adapted from that. I wrote that too and they stuck it in here. But that's old. You can see that it runs very fast and it's very blocky, but that's because it had to run on machines fast 10 years ago. So anyhow, I thought I would make C set equal to C plus, so we're going to poison a little bit more, and it should be running the opposite way from A. Plus something really small. We'll just try that. And we'll start out C at each iteration of the loop at that. So we'll move this inside this loop here. Free. Interesting. Doesn't really look as though there's a parameter varying with y, but there is. Ooh, but you're kind of getting I'm kind of getting a 3D effect because of those scallops. That's interesting. Anyway, I'm actually really interested in chaining several of these babies together in feedback, in like a feedback cycle, because of Mario Klingemann's incredible success with CycleGAN, where you have generative adversarial networks. So I'd like to see if you can get interesting feedback effect with multiple of these simple automata that don't involve, deep networks. Interesting. Okay, one more and then I'll let you go. Well, no, let's play with this a little bit more. I'm going to make that, let's play with that parameter a little bit more. Well, obviously, the thing to do is go halfway between the last two. Oh. Go halfway between the last two, so 1, 5, okay. Doesn't look any different at all. Yeah, that's better. Because I want most of the space to be taken up with interesting stuff happening. Oh, that's good. We see that we get stripes deep below the... Yeah, that's really interesting. Let's keep pushing it in that direction. Okay, so let's look over at H-top and see. Interesting. So we can see that there's one core beavering away at this cellular automaton, and there's the other cores are working pretty hard at, doing the graphics and doing the OBS and doing the compression for OBS. So we got a pretty high load average. Interesting. Okay, so I'm going to stop now and see how well my compression settings did. Okay. Thank you. I hope that you got tingles from this ASMR cellular automata stream. If you did, please like and subscribe below. Hit that like. We're streaming all day, every day, and long into the night of the Kali Yuga.